Hello grade 11s. So when I last left you, we were looking at a quadratic equation that basically couldn't factorize in the normal methods. And this was the equation that we were looking at. Now what I want to do now is I want to change it slightly. I want to multiply everything by 2 for a reason which will become clear later on. It'll become the same equation because if you multiply the same side or the equation by the same thing on both sides, it's still the same equation, but it's just going to help us understand something else. So this equation multiplied by 2 is just going to be that equation. Same equation, just everything multiplied through by 2. Now, before I actually look at how we could solve a quadratic equation like this, I want to take a slight detour. And I want to look at something called expanding a binomial by squaring. And we did cover this in grade 10, but I just want to go over the basics and look at some patterns. So, if we look at a binomial that's being squared, it could look something like that. And, if we wrote this thing out to its the long form way, we could write it like something like this. Oh, excuse me. And what we have is that. Now, if we FOIL that, we have something like this, which then simplifies down to that. And look, every time you square a binomial, you can do it like that, and you'll get the correct answer. But there's actually a quicker way of doing it. And the quicker way is to take the binomial that you have, and to look at it, and to go, look, I can square the first term of the thing in the binomial. So if we look at that x over there, that's the first thing in the binomial, and we're going to square that. And now, if I take the first thing and times it by the second thing, and then double it, I get the middle term. So x times 3 times 2, I get 6x. And now if I take the last term and square that, I get, which is a 3, then 3 squared is 9. And so now I actually get the same answer as down here, but it's so much quicker. And I want to suggest that that is a useful idea to grasp. I also want to focus on something. I want to look at, if I look at the binomial that's being squared, then I basically have that thing being squared here, the last thing being squared here, and then this middle term. And this middle term is double the size of the thing inside being multiplied. And that double in size is an important idea. Let's look at another example. So now we're going to look at x minus 2 squared. Now we're going to use the slightly quicker way that I suggested above. So, if I expand this, I get x squared. X times minus 2 is minus 4x. And minus 2 squared is 4. And if you're unsure about how I'm doing this and it seems like magic, I encourage you to write it out with FOIL and to do it, kind of the long way. And what you'll see is that there are 2 terms in the middle that get added together to give me my minus 4x. And that's great. And again, I just want you to notice how we have the sort of the end term, x squared, the plus 4, the constant term, which we can get from the original by just kind of squaring the terms there. And then we have this sort of interesting middle term, and that middle term you get by doubling the product of what's above. Okay, again, so it doesn't seem too clever at this stage, but I'm just pointing things out. And so let's go on to another example that's a little bit harder. So, if I look at this one with fractions, what is this going to look like? Well, we have equals, I'm going to take the first thing and square it, so I get x squared. I'm then going to take, I'm going to do the end bit kind of first, so minus a quarter times minus a quarter is going to give me positive 1 over 16. And then x times minus a quarter times by 2. What's that going to look like? So we have, in fact, we even put the 2 out in front. So we go 2 times x times by minus a quarter. And what we have is the x squared stays the same, but now 2 times minus a quarter, actually that's minus 2 over 4, which is minus a half. So I have minus a half x and then I have plus 1 over 16. And some people could even rewrite minus a half x as x over 2. Okay, so let's take this idea and now go back to the original problem. So the original problem, let's see if I can find it. Where has it gone to? Done that. Okay, the original problem was that question, and I'm going to go to the technique we're going to use to solve the original issue. So the technique we're going to use is called completing the square, and it comes from a guy called Al-Khwarizmi, I think, and he lived in the Middle East, somewhere around 815 to 850, and we're just going to call him Al. And we're going to use his technique to help us with this problem. Okay, so what did Al do? So the first thing with this technique is we are going to take out any common factors. And we're going to try and make sure the number in front of the x squared is, or the quadratic term is 1. So there's two ways you can do this. You can visualize it by taking a 2 out, and you can imagine then we have x squared minus 3x minus 5 equals 0. And then you can imagine that if I move that 2 from one side to the other, then 0 divided by 2 is 0, and we get stuck with, well, not stuck so much as we get back to x squared minus 3x minus 5. Now this is hardly surprising to us if we know where things started. So now, what's the next step? The next step, and this is going to seem a bit like magic, but just let it kind of wash over you first, and you'll get more used to it as we go. I'm going to move the constant term to the opposite side. So what I'm going to do is I'm going to say that I have this equal to 5. So I just moved it to the other side. And now what I'm going to do is I'm going to concentrate on this bit. And I want to try and make a square on this side, on the left-hand side. Force it to be a square. And I'm going to use the seeds of something which we did earlier. I always knew that there was sort of this weird relationship between doubling and the other term would expand it. So I'm going to focus on the number over here, minus 3. And I'm going to say, let me add minus 3 over 2 and then square it to this side. But now what I do to the one side, I must do to the other. If I don't do that, I'm unbalancing the equation. So I can't just add something to one side and not add it to the other. So I'm doing that. Now, what you see is if I take the right-hand side, minus 3 over 2 squared is actually just going to become 5 plus 9 over 4, which in fact is just 5 plus 2 1/4, which is 7 1/4. So that's the right-hand side. On this side, we've actually artificially completed a square. Well, not artificially, actually, we've completed a square, and I want to show you now how this works. Obviously, the technique is called completing the square. So all I need to do now is I go x, and I say, well, what is the number that I need to have inside here? Well, I know because there's a minus 3x above, it's going to be a minus sign between the two things. And now what is the number that I'm going to use here? Well, it's going to be 3 over 2. And this is the really, really clever bit. The key technique I did to find the number was take the middle term and divide it by 2, and then square it. And it's just the opposite process of what I was doing earlier when I was expanding, when I was timesing by 2. So I'm just going backwards in this method. So now you can check this, and I encourage you to do it. Check that when you expand this, you get back to what I started with. You'll be surprised to find that it actually works perfectly. So now what I have is I have a square on this side and a number on that side. And we have completed the square. But now remember, the goal was to solve this quadratic equation, to find what its roots were and to describe them. So let's see if we can just finish this off now. So let me make this a bit bigger, and we'll go here. So what was that final number? So we have x minus 3 over 2 squared. And what's more, I'm actually going to write, this was 7 1/4 over here on this side. So 5 and plus 2 1/4 is going to be 7 1/4. And 7 1/4 can actually be written as just 29 over 4. So let's try and get our answer now. Well, we also know that if we square root both sides, we are going to get x, let's change the color so I know it's getting a bit cluttered here, x minus 3 over 2 equals plus minus the square root of 29 over 4. Excuse my handwriting there. And now, if I take that even further, I can actually get x minus 3 over 2. I'm going to split this and I'm going to get plus minus square root 29 over 2. And the reason that works is that I had a 4 above, I square root 4 and I get 2. Okay, and now the final answer is just to move the minus 3 over 2 to the other side. So if I do that, all that's going to happen is that I'm going to have x is equal to 3 over 2, which is from the other side and it came across became positive, plus minus 29 over 2. And so, we can type that into a calculator and we can get what the decimals are. But essentially, we have figured out how to find the solutions to a quadratic equation which doesn't factorize easily. And what happens actually is, if I look at this number, if I want to classify it, in fact, this would be an irrational number. And the reason it would be an irrational number is of the square root 29. That's what we call a surd. And that irrational number, we divide it by 2, stays irrational. And when we add 1.5, it stays irrational. So it turns out that the reason that we struggled to sort of factorize this originally is that the roots were irrational and we didn't have a technique for solving this. Now, this probably has made some of you feel a bit intimidated. Don't worry. When we use it in class, we generally use an easier application of it. But this idea is the fundamental idea that we use to find the quadratic formula, and it's the technique that powers the quadratic formula. And if you're feeling stressed, take a deep breath. I promise this will get easier.